Okay, in this lesson we're going to look at the graphs of the derivative. So we've been working on finding the rule from when we get given the original function, and then we find the rule for the derivative. So if you look at this graph here on the page, so the blue graph, the blue parabola, the quadratic, that was the original one, and if you look in red, they have graphed the formula for that they found for the derivative. So if you just thought, for example, like if you had a quadratic, so say we had y equals, just making this up, 2x squared plus 3, if you found the derivative, or dy dx or whatever, or f dash, it would be 4x, 4x. So you can see that becomes a linear line, doesn't it? So here in this example where we got the blue parabola, you can see that the graph. So what we're going to do, you have to learn a few functions of the thing. So go down that over down here on here. So if we have, so we got the feature of the derivative graph in the red, and then we've got the feature of the original function with writing in blue. So if the derivative here is, so if the gradient is greater than 0, you see an increasing positive gradient in the original one. So you can see from, if you look at this parabola, from this turning point here, we see a positive gradient. So you can see that this graph, once we're on this turning point here, you can see that the red graph is above 0. That's what they're saying. So the red graph is above. If the red graph is below 0, that means we must, down here, we must have seen a negative gradient, which we have. So every time before this point here, we see that the graph is negative. So therefore this red line is under this 0 line. So remember, this is f equals 0 line. All right, so if we change from positive to negative, so we have a local maximums, but in this diagram up here, we actually have a local minimum, and you can see that the gradient goes from being negative to positive. So here in the blue, we've got it's negative, and then once it goes past that -2 line, we get a positive gradient. So in summary, what you're going to have to remember, if you've got the graph of like, you can either say f dash x or we could say dy dx. If you've got the graph of dy dx, if the original graph is positive, has a positive gradient, we'll see it'll be in this when you draw the graph of the derivative, it'll be up in this part. And if the gradient is negative in the original one, or negative, you'll see the graph down under here. Okay. All right, and we also notice when we have, if we have a turning point, so the x-intercept on the derivative graph indicates a turning point. A turning point on the original graph, okay? Or which would have been the original graph f of x. So you can see over here, we had a turning point at -2, and that's where we have the x-intercept on the red one. Okay, so pretty much when dy dx, when the gradient, the derivative equals 0, we've got a turning point. Okay, so here they're showing me a graph of the derivative function. So see, we can see here, yeah, where they're graphing the derivative function. So anytime this derivative function is up here, it means the original graph had a positive gradient. So the original graph has positive gradient. Anytime that the graph is down below this line, so down under here, we know that the original graph had a negative gradient. So had negative gradient, and then if you look at the intercepts of the derivative, so the x-intercepts for this graph, we can see here, so that was a turning point. This would have been a turning point, and this would have been a turning point. So what happened is, if you can see, we went from, this is a positive, there would have been a positive gradient. So we would have been going, if you think about your original graph, so I'm just going to draw it, wait a minute. Okay, so along here, I'm going to draw what originally was happening. Now, if you have a look here, they said it was a positive gradient until it got to -2. So if we say that, like, I'm going to mimic underneath. So positive means it must have been going up. And then when it gets to -2, you can see that it changes to a negative because it's below this line. So whatever happened, we saw this graph go up because that's a positive gradient, and then at -2 it changed or something and it went negative. Now it stayed negative until, so it was still all negative all the way down until we get to 1, and then the gradient was 0. Now it then, because it became, it doesn't become it still becomes negative, so it still goes down. And then when at 4, so here we know it was negative at 4, and then it changed to positive. So 4 is going to be a turning point of the original graph. So it was negative, and then it's turned up. So at 4, it will turn to a thing. So that's where you can tell it's a local minimum or a local maximum. So you can see up here, they're telling you that it was increasing to here, then it was decreasing. So we did that negative, and then we're increasing. Okay, so let's have a look. They've given me the original graph. So this red line is f of x. Now they want me to say, when is the gradient of this function, because remember that this means gradient, when is this gradient greater than 0? So that means, what that means is, when is gradient positive? So if you look along here, the gradient is positive. So I could say when it is positive between when x, you could say -1. Oops, sorry. So we can use set notation, and we can go x and up to 5. That's when it was positive. Now here, when is the gradient less than 0? So that's saying, when is it negative? So we can see it was negative. So when is it negative? Negative was here, and here we had negative gradients. So we could say when x is less than -1 in union with x is greater than 5. Okay, now the last one, when does the gradient equal 0? So we know that is when at the turning points. So we can just say when x equals -1 or when x equals 5, because there's the turning points there. Okay, with these questions, they said sketch the gradient function, or y, for each of the following. And it's impossible to know all the features, but we know a rough idea. So this is over here, I'm going to sketch the gradient function. So I know, well, here I've got a turning point, and I know that the turning point, dy dx equals 0. So I'm going to go at 3. So at 3, that's an intercept. So I know this graph intercepts here. Now, if I have a look, anything before that 3, that was a negative gradient. So that's got to be under this x line. So it was negative, so you just could be going negative. And then after the 3, it becomes positive. So it's above the line. And this makes sense now, doesn't it? Because this red line, this red graph, the original, is a quadratic. And so its derivative will be a linear line. Okay, we'll do another one. All right, so we're doing it again. So we're going to sketch over here. So you know the intercepts are when at the turning point. So here, so we're going to see here's a turning point. And so we're going to have an intercept at 1. So I'm just going to make that 1. And I've also got an intercept at negative 0.5. So here at negative 1.5 is another one. So let's look around that. So after the 1, we have a positive gradient. So that means that graph will go up like that. Before the 1 and all the way, so before this 1 and all the way to negative 1.5, sorry, all here, the gradient is negative, so that's going to be under this x-axis. So it might look like something like that, yeah? It goes under. Now we know it's going to intercept here, so there. And then if you look before this negative 1.5, it was positive, so it should come out like that. Now this is probably a good representation because this first graph here was probably a cubic, and if you find the derivative, you'll probably notice that it's a quadratic. So it'll look like So it would look like a parabola, and there you go. So there, that's all we can do. We don't really know all the other stuff, but we can do that much. Okay, so let's do one more. Now, here the original graph is a linear line. So if we're going to find the derivative, this should be a straight line because the gradient doesn't change for this one. So if you have a look, the gradient is positive the whole way through, and it's 1. We know, so if we looked at this and we did rise over run, we could find out what the gradient is, which we have a rise of 1 over 1, so it's 1. So the graph of this one is just y equals 1. We just would be a straight line. It's always positive and it's always the same thing. Okay.